All right, we're going to kind of start in the middle of the practice problems. We're going to work our way back, and I'll explain that in just a moment in the video. But we're looking for a total inductive reactance of this one. Now, this is a purely inductive circuit, so we don't have to worry about any of the resistance in here. But we do have some formulas we have to go through to get there. And so let's take a look. The very first thing, if we want total inductive reactance, we could either calculate the individual inductive reactance of each one of these, or we can just add them together, get the total inductance, and then figure the total inductive reactance. So that's the shorter method, so let's do that. And let's remember here that our formula for inductive reactance is 2 pi FL. So 2, and again, forgive me, but this little pen, once I get used to it, will be great. I've just got a learning curve. Wow, that's pretty large, so we probably need to change our dot size. Let's try this one more time. 2 pi FL. Obviously, so it'll be 2 times pi times frequency is 15K. And we'll talk about that, but notice this K right here. Then it's times the total, so 30 plus 20 plus 10, 30 millihenries plus 20 millihenries plus 10 is 60 millihenries. Now, milli means 10 to the negative third, K means 10 to the positive third. So these units are going to cancel each other out. But we can also use the base units, and we're going to arrive at the same answer. So I'm going to perform it both ways, just so you see. 2 pi times 2 times pi, 2 times pi times 15K, which is 15,000, times 60 millihenries, which would be 0.060. And that would be henries. And this guy would be hertz. This guy would be K hertz up here too. So forgive the chicken scratch, but you get the general idea. So let's run both these values. So I'm going to do 2 pi, 2 times pi times 15 times 60. Now again, I said these are going to cancel out the 10 to the positive third against the 10 to the negative third right here. They're going to cancel each other out, and we do arrive at 5,654, which is the same as rounding up 5.65K. But I want you to see we would arrive at that even if we used base units. So I'm going to say 2 times pi times 15,000 times 0.060. And notice we got the exact same answer, 5,654, which rounds out to here. So we could do it either way. Our formula is set up for base units, but if we're multiplying this by 1,000, which is what 10 to the positive third is, and we're dividing this by 1,000 to get millis, then if we multiply something by 1,000, then we turn around and divide something by 1,000, they're going to cancel each other out. So anytime you have kilohertz and millihenries, you can use those values, or you can just convert the base and get a number. So this is our right answer, and again, we're going to click on it, and we're going to work our way back. All right, so total impedance. Now we're getting into the part that's a little more in depth here. The very first thing we got to do is apply the 2 pi FL formula. So let's draw out that formula. 2, and I accidentally went back to my mouse. I'm doing about as good with my mouse as I am the pen. 2 pi FL. So that would be, and we're doing that based on this inductor right here. So I'm going to say 2 times pi times 250 hertz times 1 Henry. Now notice we're in all base units here. So that'll be easy. We don't have any conversions for that. So what we're solving for, and I'm going to come way over here, is we're solving for x of L, which is really x of LT, because this is actually, x of LT, because this is the only inductor in here. So let's do that math real quick. 2 times pi times 250 times 1 equals, so 1570, and if we round up, it's 1571. I'm just going to call it, if I can make this thing work, I'm clicked off, 1.57K. Now we know our total resistance. It's easy. There's only one. If there are more than one, we just have to add them. So R total is equal to 2K. Both of these are ohms. So we cannot just simply add these two together to get our total impedance of this circuit. ZT, which is the formula we need to use, is equal to the square root of R total squared plus x of L, plus x of L squared. So basically we've got to square R total, add it to the square of x of L total, and then take the square root of that. We're going to do that over here on our calculator. So we're going to say, let's clear this thing out, 2 squared plus 1.57 squared equals, and we're going to get the square root of that, 2.54. So obviously, and remember both of these units were K, so that means our answer is going to be in kilo. What happened there, but we need to make it unhappen. There we go. So both of these were in K. So here's the K for, here's the K for this guy, here's the K for this guy, which simply means this expression over here is also in K. So our answer is going to be in K. We got 2.54. We're going to round to 2.5, and there's our answer. All right, so there's that one. All right, so again, a little more complex one here, and it's wanting total current. So this is where it becomes a step. You've got to get to A before you can get to B, before you can get to C, before you can get to D, so forth and so on. You get the idea. So the very first thing we have got to seek is x of L, and that is 2 pi FL, as I've been drilling into your head throughout a lot of this video so far. So 2 times pi times F, which is 250, times 1. Okay, now obviously I didn't put the 250 hertz, I didn't put the 1 Henry, but we know what we're dealing with there. We're just doing the math. So we're going to try to get to that x of L by saying 2 times pi times 250 hertz times 1 Henry. So that is 1571. So we're going to come over here and we're going to write our x of L. Because remember, this is a process. We got to do A, then B, then C, then D. So x of L equals, we'll call it 1571 ohms. All right, so the next thing we've got to do is we've got to get R total. Well, that's easy. We only have one R, and it's 2K ohms. I'm going to express it in its base units. We could have expressed them as K, and I'll even write out here 1.57K and 2K. So either way, either of those works fine, whichever one we decide. And now we've got both x of L and RT, so now we can get ZT. Remember, ZT is equal to the square root RT squared plus ZT squared. So we got to square both of those. I'm going to use the K value simply because it's simpler in my mind. So our total is 2, so let's clear our calculator. 2 squared plus 1.57 squared equals, and we're going to get the square root of that, 2.54. So we've got ZT. Let's see if I can write this in somewhere where we can access it. So I'll come down here below this and I'll write ZT equals, and that is 2.54K. So we're getting closer. Let me get rid of this one just above us to give us some space to write with. So let's get rid of this guy because we've done all of it. And the last formula that we're going to need is this. It is IT equals E, which is our applied voltage, over ZT. So we have to divide 5 volts AC, and I'll write the units here, by, again, we can either use base units or we can use K. So let's convert 2.54K to ohms. So I had 2.54K. So the decimal place is here. If I multiply by 1,000, 1, 2, 3, that puts the decimal right here, which gives us 2,540 ohms. So that's all I did to get that value moved over for us. So let's come over. Let's do that math. 5 divided by 2,540 equals. Now this value is in pure amps. So I might have been just as well off to have kept my K, but that's okay. We'll come over here and we'll change that. I've got to move this decimal 3 places right here. So let's look at that. So right at this moment, my decimal is right here. So I'm going to move it 1, 2, 3. And that gives me 1.968 milliamps right here. Or if I do some rounding, 2 milliamps. So according to this, my answer should be 2 milliamps. So let's get rid of this stuff. Let's click on 2 milliamps. See if we're right. So there we are. So last but not least is we're looking for the voltage drop. Now we've got to get through the same amount of stuff here, and actually we're going to run out of time, so I'm going to have to end this video, come back to this problem because I'm limited to 15 minutes. So we'll come back to this and then we'll work a couple of the problems that's in your practice that actually have a little bit of issues. We'll resume in the next video.